This is our Earth Science Week presentation on an introduction to geology. I'm Nicholas Minton, and this is my email right here. I am a GSU geology student, and I plan to graduate in summer of 2022.
Hello guys, my name is Mamadou Cisse. I'm a geoscience student at downtown campus Atlanta, GSU. So I will be graduating this summer. I mean summer 2022 also. So and then this is our presentation.
All right. The purpose of our presentation is to introduce GSU students at the perimeter campuses to the basics of geology and show them the kind of things they'll do and learn about in the geosciences major with a concentration in geology at the downtown campus. This is primarily made for students that have either not chosen a major at all or have chosen to major in geosciences but have not decided on their concentration yet.
Um, this uh, this presentation we will walk us through a brief introduction to some of like the most important topics on geology, such as petrology, hydrogeology, mineralogy, and so on. We will also touch upon the opportunities that Atlanta campus offers to students coming from other campuses that will be really important.
So, what is geology? Geology is a field of science that studies the Earth throughout time. So, it can be used to theorize about the Earth in its past, its present, and its future, and then compare those. It can be broken down into two different branches. Historical geology would be the history of how geology has evolved over time as a science and gives us a timeline of the geologic history of Earth over a very large amount of time. And physical geology would be the study of the physical properties and processes that dominate the Earth and allows us to study the natural resources that the Earth can give us. So, why is it important to study geology, and why should you choose to study it? Well, geology can help us discover more natural resources on the Earth. It can help us understand what has happened to the Earth in the past, and that in turn could allow us to understand what might happen to it in the future, such as predicting natural disasters. It can help us optimize the usage of our natural resources that we do have, and it can help us understand climate change and how it affects all of us. So, a brief history of geology. Geology is often considered to be the youngest of the major branches of sciences. So, for many years, the geosciences were limited to cartography, map making, and the general study of rocks. But in 1788, the British geologist James Hutton, often referred to as the father of geology, published the theory of the Earth in his greatest work. And he proposed the concept of uniformitarianism, which basically means that things that processes that happen on the Earth happen the same in the past, present, and the future. So, a modern study of geology was not realized until the 1960s, when the theory of plate tectonics was proposed, and it became accepted after a while because of evidence that was found by observing the Earth's magnetic field. Originally, German scientist Alfred Wegener in 1912 proposed plate tectonics as a theory, but scientists around the world at the time dismissed his claims as too fantastical. Also, Mary Tharp made studies of the seafloor based on detailed maps that she created, but she was not permitted at the time to go to sea because she was a woman. But she helped to bring to light important features that could be seen on the bottom of the ocean and demonstrated that the continents had indeed been moving over time. So, we have a question for you guys. If you've been paying attention so far, who wrote the theory of the Earth? Take a moment to pause the video and think about an answer. All right. Here is the answer to this question. James Hutton. All right. This is the geologic timescale. You can see over to the left, we have an image that shows the geologic timescale. I'm not going to go over the entire thing because that would take a long time, but you can see that the timescale is broken down into eons, eras, periods, and epochs. The Earth is dated to have formed about 4.6 billion years ago. To recognize the significance of the different periods in Earth's past, geologists designed this timeline of past events and gave names to the different periods of time before and after events of interest, which were usually mass extinctions that wiped out a lot of the life on the Earth. So the eons are divided into eras, which can be divided into periods, and then those periods can be split up into epochs. It has been proposed that the current epoch listed on this timescale via Holocene could actually be the Anthropocene, which occurs after the Holocene, since human activity has increased the background extinction rate of species on Earth to about 200 times more than what is considered normal. This is our second question for you guys. What is the age of the Earth? So again, take a moment to pause the video and come up with an answer, and then I'll reveal it to you. All right, the answer is 4.6 billion years ago. Hope you got that right. Here's another question, and this will help you understand why it's important to study mineralogy, which is a branch of geology. So look at these two pictures here, and can you tell me which one is pyrite and which one is gold? So take a moment to think about that. Surprise, both of them are pyrite. Neither of these is gold. Pyrite is also is often referred to as fool's gold, and it can catch many people up if they haven't studied mineralogy and don't know the key properties of the different types of minerals and be able to distinguish between them. In case you were wondering, this is real gold up here at the top right. You can see how similar it looks to pyrite. All right, an introduction to mineralogy. Minerals are naturally occurring inorganic substances that have an orderly internal structure. Mineralogy, as a science, is a way for geologists to identify and characterize the different types of minerals. The key properties of minerals that geologists use to characterize them are color, hardness, specific gravity, cleavage, fracture, luster, and streak. And so you can take a look at these for a minute. Understanding and knowing minerals also allows geologists to characterize rocks according to their composition. So you can see here, this is a list of common minerals and some pictures of them. And then this on the right is a Balance reaction series diagram that shows the order at which different types of minerals cool in magma or lava, and also how the different types of minerals and the different compositions in the lava or magma can determine the type of igneous rock that could form from it. In Geology 4015, Crystal and Optical Mineralogy, you'll have many opportunities and activities, such as being able to work hands-on with many rocks and minerals that you've not worked with before, to identify them by measuring their properties which were previously listed. You'll be able to learn about the internal crystal structures and the structured types of those minerals and how they affect the properties of the mineral. You'll be able to use polarized light microscopes to view mineral slides and see how they react with light. And you'll also learn how to sketch those mineral slides when viewed under the microscope, so you can identify key features, and that will allow you to identify which type of mineral they are at a very small scale. Final question here is, list any three properties of minerals. So these can be any of the properties that were listed before. So take a minute to think of those and list them out here. Color, hardness, specific gravity, cleavage, fracture, luster, and streak.
All right, on this slide over here, we're gonna go over a topic of geology called petrology. This class is offered at downtown Atlanta. So, and then when you take petrology, petrology is a branch of geology, more specifically, a branch of physical geology that studies like rocks. So, what is a rock? A rock is an aggregate of one or more minerals. That means is a combination of one to many minerals that come together to form what is called rock. So mainly we have three type of rocks. The first ones are called igneous rock, and then the second type are called sedimentary rocks, and then the third ones are called metamorphic rocks. So we're gonna go over each one. So and then if we take for example like the igneous rocks are rocks that are forming from the cooling of magma inside the earth or near at the surface of the earth. So the magma cools down inside the earth of inside the earth, it will form rocks called intrusive igneous rocks. If it cools down at the surface of the earth, it will it will form rocks called extrusive igneous rocks. Here we're going to talk about sedimentary rocks. As we said previously, we have three type of rocks: igneous, sedimentary, and metamorphic. Here we're talking about sedimentary rocks. Sedimentary rocks, by definition, are rocks that are driven by the weathering, the erosion, the transport, and deposition of pre-existing rocks. This means what? We have to have rocks first that can be either sedimentary, igneous, or metamorphic rocks that will be like weathered, eroded, transported, and deposited somewhere to form what is called sedimentary rocks. Sedimentary rocks are found either at the surface of the earth or nearby. And then we can characterize them by something called like sorting, texture, and composition. And then we said again, we have like the third type, which is called metamorphic rocks. These are rocks that are have formed from the modification of the chemical and physical properties of pre-existing rocks on the high temperature and in pressure inside the earth or nearby the surface of the earth. And then these metamorphic rocks, when they form, they can either be foliated or non-foliated. So mainly we have four type of metamorphism that can give us metamorphic rocks. The first one is called contact metamorphics. The second one is a regional metamorphic, and then the third one is a hydrothermal, and then the fourth one is at subduction zone. On this slide over here, we have like a really important event that's called a work cycle. Over here is kind of how come we can go from one type of rock to another one. So this is, as you can see, is kind of like a closed circle, like 360. You start at zero and then you come back to zero again. So everything starts right here where we have the magma that's inside the earth of the surface. It is really hot, and then this is at high temperature and pressure. It will try to make its way up. As it goes up, it will start cooling down since the temperature will decrease. So when it cools down, it can form what is called igneous rocks. This process can happen inside the earth. Then we have what we called previously intrusive rocks, or if it happened at the surface of the earth, then it is called extrusive rocks. And then we have the igneous rock. These rocks will be then after like a many like millions and millions of years will be weathered and then eroded. And then after these rocks get weathered and eroded, they will be transported and then to be deposited somewhere. So and then when they deposit over and somewhere on the earth of the surface, millions and millions of years after, it will become like sedimentary rocks. And then these sedimentary rocks again can be buried back again at high temperature and in pressure to give us what is called metamorphic rocks. And then these metamorphic rocks also can get like buried deep and deep again to melt under the temperature and the pressure, and then to give us what is magma, and then the magma can go back again to give us igneous, and then the cycle will start over again. As we can see over here, we can go from igneous to metamorphic to sedimentary, and then everything is possible. At downtown Atlanta campus, there's an opportunity to take a class called sedimentology and stratigraphy. So this is a really important geology class. When you take this class, you will understand. So sedimentary features such as like you have opportunity to look at like cross sections, like many things. If you look at the right over here, you can see like a nice picture where you have like many type of layers being top of another at a different angle. So to really understand what's going on over here, you need to take this class, and then this class is offered at downtown Atlanta. So that we have another class that's also offered at Atlanta campus downtown. Is called igneous and metamorphic petrology. As we said previously, petrology is the focus of studying like rocks. So when you take this class, you will have an opportunity to learn what really happens, what really happened when the magma is cooling down. What are the steps during separation? of the magma. You will also learn like the chemical structure of different melt and how they crystallize. You will learn how metamorphic rocks form from other rocks and then which one comes from which parent rocks. Parent rocks means like the pre-existing rocks. Here we go again. We have a question that we listed as question number 5. And then we're gonna ask you if you can list us the three main type of rocks we have. You can pause the video and then give us an answer. I hope you were able to say that we have the three main type of rocks are sedimentary, metamorphic, and igneous rocks. So this slide talks about what is called natural disaster. As we introduced at the beginning, we said like geology is a science that studies Earth through time, meaning from the past to the present and the future. The future means like what's going to happen to the Earth. So the natural disaster can be either earthquakes, volcanoes, and many other things. Over here, we're going to focus on mainly on two main natural disaster. The first one is what we call like earthquake, which is just like when the ground is shaking. And then the second one is volcanoes, which is really important, which means like when the magma comes on the earth of the surface, so it then is called like lava. So these volcanoes, we have people today, I'm just going to say, we have people today that mainly focus on studying like volcanoes on earth and even on the other planets. Over here at the Atlanta downtown campus, we have an opportunity to take also a class called environmental geology. So when you take this class, you have a lot of opportunities, such as learning how to test like wells by using a method called probes, and that we will be dropping inside the well. You will also learn about like different way fresh water and then salted water interact in areas that they meet and how they affect the surrounding ecosystem. You will also learn about glacial ice movement as it recedes in it or advances on land or in water. You will also have the opportunity to take a class called an introduction to hydrogeology. So hydrogeology is a branch of geology that study the occurrence, distribution, movement, and the properties of water on Earth. So in hydrogeology, we have an event that's really important called like hydrogeologic cycle. By definition, the hydrogeologic cycle is an unending, meaning like it doesn't stop movement of water by infiltration, transpiration, and then evaporation. So mainly this event called infiltration, transpiration, evaporation happens in like in spheres, and then these spheres are subdivided as hydrosphere, atmosphere, geosphere, and then biosphere. In this slide over here, it explains the hydrogeologic cycle. As you guys know already, everything starts inside oceans. On oceans, we have like water, tons of millions of water that's gonna be heated by the sun, and then it will be evaporated. So then after evaporation, it will come to the atmosphere and then to condense together. And when it condenses together, it will precipitate and then come back on Earth as like rain. When it rains, either it will be infiltrated into the Earth, or it will be drained back again to the ocean, and then the same event will start back again: evaporation, precipitation, rain, infiltration, and then transportation to the ocean. Why does it matter to study hydrogeology? As you guys know, so we can stay without water. No water, no life. So also there are people today who have business in only like businesses that focus only in hydrogeology by pumping water and then distributing like to houses, companies, and then they make money out of it, and then they have employees. Also, when you take agriculture, we need water to grow our plants. And then this branch of geology also help us understand some geologic actions such as weathering, erosion, landscape alteration, and then everything. Over here, this slide is just about like the distribution of water in the earth. So this one can we take all this information from the book we have already on our works cited page. So based on the book, they say that on the earth of the we already know that the earth of the surface of the earth is covered by about like 70% of water. 70% of the earth of the surface of the earth is covered by water. So and then that 70%, 96.5% of that water is only on the oceans. 1% are saline lakes, and in groundwater, 2.5% is fresh water on the surface of the earth. Out of those 2.5%, 68.6% is in form of glaciers and ice sheets. 30.1% is in the form of groundwater. 1.3% is in form of surface water and other fresh water. Out of that 1.3%, 20.1% is in form of lakes, and 2.53% is in form of swamps. And then when you take this class called hydrogeology, and then you will have a lot of opportunities and activities. The activities are like the opportunities is going to help you understand what is an aquifer, and then the type of aquifers are like such as what is a confined and unconfined aquifer. Also understand like the groundwater flow and then its calculation. It will also help you understand the process of investigating and then the decontamination of groundwater, since today like the human activity is really affecting like many groundwater. You understand the process of groundwater, the process of drilling groundwater. Here we go again. We have question number 6. The question is, what is the term that refers to all water on the earth? I hope you guys pause the video and then come up with an answer. The answer to the question is hydrosphere, and I hope you guys were able to find the right answer.
So the downtown Atlanta campus offers many opportunities for geology students moving from the perimeter campuses that you may not have had before. The Atlanta campus can offer connections to companies, governmental agencies, and nonprofit organizations that can offer internships and jobs. The downtown campus also has labs where the students can get involved in research as part of their classes or through independent study work. The community of students downtown includes many clubs and offers many extracurricular activities, which can offer opportunities to find and interact with other students with similar interests in a social atmosphere. There are also a number of funding mechanisms and scholarships available to students downtown to help for paying for field courses, travel to conferences, and other support for students that are looking to pursue a career in the geosciences. This is our works cited page. We're not going to go over the survey here, but it'd be very helpful for us if you guys would take the time to answer these questions and get back to us. This is our email information. Once again, if you're looking for any questions, or there was something here that you're not so sure about, or if there's something that wasn't here that you want to know more about, feel free to look us up and ask us any questions you have. Thank you.
Thank you, guys.